So now you see from the structure of atom, small, okay, test, okay, one small worksheet we are doing. So see here now, first question, these are multiple choice questions. In the Thomson's model of atom, which of the following statements are correct? Okay, so first one is what, the mass of the atom is assumed to be uniformly distributed over the atom. Second point, the positive charge is uniformly assumed to be uniformly distributed over the atoms. The electrons are uniformly distributed in the positively charged sphere, and the electrons attract each other to stabilize the atom. So here four options are there, and in that term, okay, so some statements, maybe two, maybe three are correct. So can you guess, can you say which statements are correct in this one? About the Thomson's model, okay, Thomson, what plum pudding, okay? Yes. So the Thomson model, like watermelon model, I said you. Did you remember? Now which answer might be the correct in that? So option A is 1 and 3, option B is 1, 2 and 3, option C is 1 and 4, option D is 1, 3 and 4. So which might be the correct? So which option is correct here? A, B, C, D. 4 are there. Which options are correct? Out of 4. Thomson model.
Yes, sir. Option 1 and 3.
1 and 3. Why can't B?
The positive charge is to be uniformly distributed on the atoms. Yes, sir. B.
So B is the right option. Okay. Why? Because he said no. The watermelon in that the total, if you cut, you can see the red coloring mass is distributed, right? So how the total red coloring mass is distributed, like this, positive charge is distributed, he said. Okay. So the answer is, okay, the second statement is also correct. So the option is B is the right answer. Is this clear? Right. Now then go to the second question. When alpha particles are sent through the thin metal foil, most of them go straight through the foil. Okay, which experiment that is? Very good experiment. Who conducted this experiment? Rutherford, very good. So in the Rutherford experiment, the alpha ray scattering experiment. So what is saying? When alpha particles are sent through the thin metal foil, most of them go straight through the foil. Most of them, okay, penetrated through the foil. Now, what might be the reason here? So four options are there: A, B, C, D. First option: alpha particles are positively charged. Alpha particles are much smaller than electrons. Alpha particles move with low velocity, and most of the atom is empty. So which is the right answer? Yes? D is the right answer. Most part of the atom is empty. So that's what most of the alpha particles pass it, okay, through this gold foil. Very good boy. Then go to the third question. Which of the following statements about the Rutherford model of atom are correct? So here four statements are given to you. Okay, which of the following statements about the Rutherford model are correct? Okay, first one is what? Consider the nucleus as positively charged. Okay, considered as nucleus is positively charged. Second is what? Establish that the alpha particles are 4 times heavier as a hydrogen atom. When you compare with the hydrogen atom, they are 4 times or heavier. And third one is what? Can be compared to the solar system. So Rutherford atomic model compare with the solar system. Fourth one, it was in agreement with Thomson's model, means it was obeying. Agreement means what? It is obeying. Okay, the Thomson model were correct. Now, in these four options, which options are correct for this one? Yes. Think which of the following statements about the Rutherford model of atoms are correct. Are you there? Yes, can you hear me? Okay. So here, which of the following statement of Rutherford model correct? Or consider the nucleus as positively charged. Is this statement right? Yes. Okay. So here, according to Rutherford, okay, the most of the space in the atom is empty, and there is a small region is present at the center of atom, and that region is called as nucleus, in which total mass means almost all the mass and total positive charge is situated, okay, at that nucleus. So the consider that nucleus of the positive charge is right. The first one is right. Okay.
Yes, sir.
Can you hear me?
Yes, sir. Yes, sir, you're audible, sir.
Right. Now, second one you see, establish that alpha particles are 4 times or heavier than. This is not about the Rutherford model. Okay. So, we don't consider this one. So, this is not about the Rutherford model. Now, can we compare with the solar system? Yes. Rutherford said that planets like electrons will be revolving around the nucleus like planets around the sun. That's what Rutherford model is also called as what? A planetary model. Yes or no? So, the third statement is also correct. Fourth one is what was in agreement with Thomson model. Whether it is obeying the Thomson model, according to Rutherford model is obeying. Is obeying means what? Rutherford agreed that Thomson model was correct. No.
What is considered, sir?
So here only first one and third one are correct. First and third option is what? A. So A is the right answer. Is this clear? Now come to the fourth one you see now. The ion of an atom has two negative charges. One ion is there, it has two negative charges. Okay, means -2. Its charge is -2. Okay. Mass number of the atom is 16. Mass number of the atom is 16. And the number of neutrons are 8. The number of neutrons are 8. Now, what is the number of electrons in an ion? Okay, so first you find what is atomic number. Mass number is given 16, number of neutrons are given 8. Now, what is its atomic number?
8, sir.
8, very good. So, 8 is the atomic number. So, atomic number 8 means what? There are 8 protons and 8 electrons will be there. Yes or no? Right. But here you see, here it is given that atom has two negative charges, means -2 is there. So, now the number of electrons how many? 10, because its atomic number is 8, means 8 protons and 8 electrons are there. Okay. So, when 8 electrons and 8 protons are there, that atom is neutral, means no charge. Okay, it is neutral. But here it is showing that -2. -2 means what? It has 2 excess electrons. It has excess 2 electrons. So, already it has atomic number 8 means what? Already it has 8 electrons. But -2 means what? It has 2 more electrons. Okay. So, 8 plus 2, 10. So, it has 10 electrons. This is the right answer. D option is the right answer. Is this clear? Right. Now, come to the fifth question. Anode rays are produced. Anode. So, two rays are there. Cathode rays and anode rays. Cathode rays, okay, and anode rays. So, but here asking about the anode rays. Anode rays are produced when cathode is perforated, anode is perforated, when low voltage is passed, when pressure is high. What is the right answer? Yes?
Of A, sir.
No, cathode ray not perforated, so B is the right answer. So here anode is perforated. When anode is perforated, then the anode rays are released. Okay. Now, the first model of atom was given by Niels Bohr, Goldstein, Rutherford, and Thomson. Who gave the first atomic model?
J.J. Thomson.
Very good. J.J. Thomson was the first atomic model. Next, the relative atomic masses of many elements are not whole numbers. Okay, so most of the elements atomic masses are not whole numbers, not exactly like 1, 4, 6, 8, like that. Okay, so they have small difference. Like, okay, if you take oxygen for example, oxygen atomic mass is 15.998. but we write this as a 16, as because 15.99, so that's what we are writing 16, but actually it's not a, okay, 16, 15.998 and so on. Now similarly, for example, if you take the chlorine atomic mass is 36.5. This is also not whole number. Whole number means what? Like 1, 2, 3, 4 fractions, means points should not be there. But chlorine atomic mass is 36.5. Like this, most of the atoms atomic mass is not whole number. Okay, why? What might be the reason? So here 4 options are given here. In that, one option is correct. Okay, the relative atomic masses of many elements are not whole numbers because first option, due to the presence of impurities, maybe impurities are present inside. 2, they cannot be determined accurately, so we cannot determine them accurately. And third option, of the existence of isotopes, okay, because due to the existence of isotopes. And fourth one, none of this. So in this, one of the reason is there due to which the atomic masses do not exist in whole numbers for the most of the elements. So what might be the reason? Yes? What is the right answer? So this is the answer, not this. This is actually both printed B only. This is C. So here existence, due to the existence of isotopes. Okay, right. Now let us see the next one. In Rutherford model, in the Rutherford's gold foil experiment, see here most not, here few rays, here the word is misprinted. So this is, that should be few, okay, that should be few. Few of rays returned back, okay, to its path, showing that. So here already we discussed that most of the rays are passing straight, okay, through the atom, and few rays are deflected with different angles. Very few rays are rebounced back, means coming back, exactly coming back. So why these rays have come back? What might be the reason here? One, most of the atom is hollow. Second one, atoms have dense nucleus at the center. Third one, atom is spherical. And 4, atom is neutral. What might be the answer here? Very good. Atoms have dense nucleus at the center. So at the center, a small region is present. Okay, that is called nucleus. And this nucleus means almost all the mass of an atom is present in the due to the nucleus only. So the nucleus of the atom is more dense. Okay, so due to that, this rebounced back. Very good. Now next one, the valency of aluminium is, aluminium with atomic number 13, is B is the right answer. Okay, so aluminium 13. How do you write the distribute the electrons? Electrons will distribute like electronic configuration. How do you write 2, 8, 3, 2, 8, 3. So the valence shell means last shell. How many electrons are there? 3 electrons. So the atomic, the valency of the aluminum is 3. Is this clear till here? Any doubts? Right. Now, a little description questions are there. Okay. So, once check this one also. Electron attributes negative charge. Okay, means electron has a negative charge. Protons attribute positive charge, means proton has a positive charge. An atom has both positive and negative charges. But why there is no charge? Why the atoms are neutral? Can you say why the atoms are neutral? Very good. So in any atom, the number of protons is equal to number of electrons. So protons carries a positive charge, electron carries a negative charge. The amount of positive charge is equal to amount of negative charge. Hence, their atom is neutral. So that is the reason. Okay, atom has no charge. Very good, boy. Very good. Now, write the electronic configuration of element whose atomic number is 12. Okay, can you write the electronic configuration of yes, 282. Very good. What is that element? Atomic number 12 is the element name. Magnesium, very good boy. Right. Now, list three distinguishing features between the models of atom proposed by Thomson and Rutherford. So, the meaning is what? You have to explain three differences between the Thomson's model and Rutherford model. Okay. Can you explain what are the three differences between the Thomson's model and the Rutherford model?
The Thomson model, Richard explained that the nucleus is very dense, sir.
Very good.
He also not said about the most of the space is empty that.
Mm. Yes. Okay. So the difference is that first point is that according to Thomson, the total positive charge is distributed throughout the atom. Okay. So positive charge sphere is said. Atom is nothing but a positive charge sphere in that electrons are embedded. Right. So according to him, the positive charge is totally distributed throughout the atom. Okay. But Rutherford, what he said, the positive charge only is present in the nucleus. Yes, so that is the first difference. And the second difference is what? In that positive charge, electrons are embedded. But what he said, Rutherford, electrons will be revolving around the nucleus. Okay, that's the second difference. And third difference, Thomson did not explain about the presence of nucleus. Okay, and Rutherford explained the presence of nucleus. Is this clear? And total mass is also distributed throughout the atom according to the J.J. Thomson, but according to nucleus, only the mass is concentrated at the center. Yes? And atom is totally distributed with the positive charge and electrons, but here, according to Rutherford, most of the space in the atom is empty. Yes? So, these all are the differences, okay, between the Rutherford and Thomson's model, right? Now, write the electronic distribution of chlorine atom. How many electrons are there in L shell? So, here chlorine atomic number is 17 is given, and you distribute the electrons, means electronic configuration you write, and in that L shell consists of how many electrons? What are the number of electrons that present in the L shell? 8, very good. So, K, L, M. First shell is a K shell, second shell is a L, third shell is M. Okay. So, we write the electronic configuration as what? 2, 8, 7, as it is 17. Okay. So, K shell consists of 2 electrons and L shell consists of, okay, 8 electrons and M shell consists of 7 electrons, 2, 8, 7. Good. Now, here you say elements A, B, C, D and E have the atomic numbers 4, 9, 13, 17 and 20. Okay. Now, write the electronic distribution and determine their valency. So, here A, B, C, D is there. Here the shells are given, K, L, M, N shells are given. Now, you have to distribute the electrons. So, first let us take A. So, 4 are there. How can you distribute the electrons? 2, 2, very good. 2 in the K shell, 2 in the L shell. Next, B is atomic number is 9. How can you distribute? 2, huh? 2, 7. Very good boy. 2, 7. Next, C is atomic number is 13. How do you distribute? Good. Next, D is 17. How do you distribute? 7. Good. What is 20? No. 2, 8, 8, 2. Like this you have to distribute. Okay. So, not 10, 2, 8, 8, 2. Actually, the M shell can accommodate, of course, 18 electrons, because we have the formula that 2n square. Yesterday in the last class we discussed 2n square. So, in any orbit, the maximum number of electrons accommodated is given by the formula 2n square, and M value is 3. So, 2 into 3 square. So, 2 into 9, that is 18. But while distributing here, we don't write 18 here. First, we write 8, then we distribute to the, okay, 2 there. Again we come, that we learn in the next classes, okay. I'll explain you why that takes place, okay. Right. Now come to the next two questions. Acha, here some definitions are there. Define atomic number. How can you define the atomic number? The number of protons present in the nucleus of an atom is called atomic number. Next, how can you define the mass number? How can you define the mass number? The sum of the, okay, sum means what? Addition. The sum of the protons and neutrons present in the nucleus is called as a mass number. Good. What are isotopes? How can you define the isotopes? Atoms of same element having same atomic number but different mass numbers are called isotopes. Good. Okay. So these are the isotopes. So let's see some uses of isotopes. Yesterday we discussed isotopes of uranium is used in the nuclear reactor as a fuel. Isotope of cobalt is used in the treatment of cancer. Okay. So this we can write the uses. Okay. So today you have joined later. Some other questions are there. Let's see later because I have a class at. Okay, you two have a class now. So will you? You can leave now here. Okay. Okay. Take 5 minutes break and then join in your next class. Right. Okay then. Bye.